All right, so this week we are going to talk about two important aspects of databases that we have not discussed before. One of them will be indexes or indices, whatever you call them. And the second one will be transactions. And that is the transaction is an important part of it, or we'll start with the indexes and then we'll go with that one. So that's as I said that they are one of the important aspect of any of the databases. So let's start with the indexes first of all. What is indexes or why indexes? So, imagine a book of 10,000, what literally 100,000 or something more than 10,000 or something, pages without index, either at a start or back. If we have a book and we don't have an index, index means we don't have any numbering, any something that would guide us to a particular chapter, to a particular topic. There is no index at the beginning. There is no index, or there is no sort of, something that is at the end that could give us a hint that which page might contain what. So, if it's a book of that much pages, millions of pages, and it's without index, you can imagine how the life would be very difficult to find something on that. And on top of it, maybe let's talk about on top of it, that is not even, maybe in an on any order, ascending, descending order. And usually it's not in ascending, descending order. Chapters can be randomly, not ascending or descending. Anyhow, so this will create a chaos. If we talk about this one, it will practically create a chaos. It means that if I say I give you a book of 10 million pages or something, and I say that, find out the topic of transactions in this book of database. So you will say that, it will take ages for you to just go and find out something out of that one. So need to check every page if index is not there. So again, typically what you will need to do is that you will have to go through every page if you want to look something. Now here comes those techniques. They come very handy for us, which actually give us some of the technique, but anyhow, we are saying that here we don't have any, specific order of something chapters. And as I said, book chapters usually do not have any coherence or like, the order, ascending, descending order. They can be of any names. It's against that of, maybe the dictionary. The dictionary is basically in ascending or descending form. So there is a little hint that you will be able to find something typically. But if that book does not have an index and you have to find out some topic, it means you will have to work really hard to get that. In a similar world, indexes can help the query to find data more quickly. Now, here comes that concept. We have been talking about a lot of queries before that. We have talked about a lot of queries, and those queries we were working on. And if you guys remember that when we run a query, it actually comes up with a result. The result that it comes up with is basically, it contains the execution of our query. But have you noticed that we have got a timer that runs on at the bottom of the screen, and that timer actually tells us that how much time this query has taken. And you see that, sometimes at times you will see that some of the queries, they would take a, a a reasonable big amount of time to just get to a result. And that really is something that is a point of concern. So in the database world as well, we have got something called index, like the book index. That index would make our life easy in a way that the query will not have to go to particularly each and every record to find out something. Rather, what a query will do, it will just, go to a particular area and try to find whatever it is looking for. And that's a very important aspect of it, that it will go to a particular page and just find out that. In fact, indexes improve performance of queries dramatically. And again, we can sense that if there is an index and I want you to just, find out something in that particular book, You can pinpoint to that chapter by using the index, and you can just go to the chapter and find out. Maybe there are hundreds of pages and that or, but finding out in million of pages or finding out in 100 pages or 200 pages is much more simpler than that one. So again, in the same world, in the similar world, the indexes, they really help queries to find data more quickly. And we'll look at some of the examples, very nice examples that would really give us this facility of having our queries going faster. So we'll see that. Okay, let's move forward. So example, a huge table with no index on salary. So look at that. Let's talk about, just given as an example, but let's consider there are millions of employees, for example, or millions of people with some salaries. And everyone has, like, for example, 10,000, 13,000, 5,000, and any number of salaries. And there are, again, just consider huge. We are saying that it's not three values. Of course, you can very easily find that one. But let's talk about, there's a huge number of employees are there, and we are gathering the salary of them. Now, if I run that one, select a statistic from employees where salary is greater than 6,000 and salary is less than 12,000. Now, this is a very classical example. So again, consider there are millions of records, and I have to find a salary greater than 6,000, less than 12,000. Now, do you feel that I will have to literally go to every record salary column, every field, and I'll have to check this with the condition. Okay, 10,000 comes in between. Okay, this is the one, Paul should come. 13,000 is out of this range, so I don't want this Anna's record. 5,000 is not inside this record, it's less than that, I will leave that. But do you know that if there are millions of people over here, there are millions of rows, like, we are talking about a very realistic world, or that world where there is lots of amount of data. We are talking about that environment. So if that is the case, what will happen is that I will have to literally go into every record, go to the salary, find out the salary and compare it with this, and just leave that record or add that record, leave that record or add that record. Make sense, everyone? To find all employees from a large database. So now when we say large means we are really talking about a large database. The query engine has to check every row for particular range salary. So again, that I talked about, if I give you a record of 1 million people, and I say that take out the names whose salary is greater than 6,000 and less than 12,000, and you will have to literally go to every record and try to find that one. In the same way as we have talked about the values. Now, so it's a table, a huge table of salary or something, which has no index value on salary. This is very important. This is the point comes. The index value on salary is not there. Okay, what can we do? Let's come in. We can create an index of salary over there. How come? We can say create index, and generally index have this prefix of IX. IX underscore employee underscore salary on employee salary ascending. Now that's a very interesting one. I want to create an index on employee table by using the salary ascending. Are you guys getting that one? It means that this salary over here, it will go in ascending form, right? So 5,000 will come here, 10,000 here, 13,000 here. So there will be an ascending form, like there will be an order, and it will create an index for that one. What is the benefit of that? This will store all salaries in ascending order, and now it's easy to find the relevant records. Do you know that if these millions of records, again, we are considering them millions of records, we are just supposing them. If these were the millions of records and there is a particular window that I will just check, and that window will start with 6,000, for example, and end at 12,000. So I won't check any records before 6,000 or after 12,000, but that will only be possible if I make an index on the basis of the salary over here. On the basis of salary, if I have created an index, that index I can use to find out the typical amount of salary. So I will go to a particular window and then I will find out that particular salary over there. So how to make that? Now look at that. This is very important. So this will store all salaries in ascending order, and now it's easy to find the relative row. Now this is here. It stores the row address with salary range in an index, and SQL picks up the row address and brings only required rows. It is called index seeking. Remember this because it has been mentioned in a bit of bold form. So it is called index seeking. What will happen that the address will come as a row address. So every row has an address, and this will be basically it will be given an address, and when it will just make it ascending order, those particular rows will be so there. So what it will do, the row addresses will be saved with the salary range index, and SQL picks up the row address. It will go to the particular row address and it will just bring only required rows. So that required rows will only come up, and that is called index seeking, index seek, right? Let's go back. Now let's do that. So again, we'll see some of the examples, and we'll just try to have that one, and we'll create that index. Create index, that is employee salary on employees city. It's basically for the city ascending. So if city ascending is particularly if you are trying to find out the city or something, but we can just do that. Now let's me open that and let's try to find out a table over here, and we'll try to just come up with. Right. So let's come here and let's do practice for today, and I'll just mark the date today, July 10, 2024. Right. So which database we were using last time? Sorry. Which database we were using? Let's see that. Let's see that. AP is good, I think. AP, let's see the tables. If any salary table or something is there, invoices, when, why not? Let's talk about invoices. Let's see the invoices. So let's use AP and let's say select asterisk from invoices. Let's run both of these two commands. Okay, we have got the salary, we have got the invoices over here. Now invoice total, that's good. You see that invoice total is all random. And again, if I want to find, see, for example, there are 114 rows. It can be, more than that rows or anything at all. But let's talk about this one. So for example, invoices. So where I would want to say, for example, if I say where, let's say invoice total is greater than 50 and invoice total is less than, for example, 200. Something like that. If I want to find out that one, look at that. So you say 29 rows are coming up. Invoice total, which is greater than 50 and less than 200. Look at that. All those invoice totals are coming up like this. But do you sense that one, Daniel and everyone? Do you understand that? Actually, for this one, it has actually gone to every row and tried to find that. And again, right now you see that the query time looks like 0, 0, 0, 0. It has not taken that much time. But think about an environment where there are millions and trillions of rows. It would take a good amount of time to find and read about every row. Are you guys getting that one? Why not? Let's make that like this. Select asterisk from invoices. I'll just keep all those over here. Now let's come back over here. And we wanted to create what? We wanted to create an index. So let's create an index. I'll copy this one. And again, of course, I'll just, change that up again. So I'll just come here, create index IX, not employee salary. Let's say invoice amount. Invoice amount on invoices. And here I would say invoice total. Invoice total ascending. Now if I run this one, look at that. I've got an invoice. Let's go back and see how it would use that. So find all the indexes available to employees table. Now, how many indexes are available to my particular tables? We can use this command with the table name. First of all, let's check that one. So SP help index, and I'll say invoices. How many indexes are there? Let's execute this one. So it says that it has two invoices. One is PK invoices, primary key for invoice ID, and we'll talk about this clustered, non-clustered and everything. This is very interesting. But right now, just look at that one that we have created. IX invoice amount, non-clustered, look at the primary for something like that. And index keys is invoice total. And it has just done what? It has just created an invoice underscore amount that would have, if you just look at that one, this index, that would. So now let's go back there. So drop index, if you want to drop that one, and now by console, we can just, drop that one, or we can just, work with that one. That is all we can just check over there. Okay. So this is, we have created index. Now, if I just come back over here and I'll show you something. If I refresh this one for a second and I go to invoices, look at that indexes. If I open that indexes and if I just come over here, this is the index, invoice amount that I have created, the invoice. So if I just come over here and if you look at that, like it's just showing that one. So if I just come over here and if I say this is, we can script that index, we can create two, we can drop two, we can have storage, we can have policies, facets. There are lots of things that we can do, and we can use this one. Now by using this one, we can just access particular amount of record. That way that would be there. So now we'll just use that also typically. But let's come here. Types of indexes. What are the types of indexes? Now, types of indexes include, and these are very interesting: clustered, non-clustered, unique, filtered, XML, full text, spatial, column store, index with included columns, index on computed columns. Simarjit, you have a question?
Yes, it's like we have created an index. So how did our database changed according to that? Like, will that index contain the amount that will reside between 50 and 200? That will
Mhm.
come under this category.
No, not at all. I'll just let you know, and I will use that as well. Actually, what it has done, it has created an index over here. If you look at that, this index, and
Okay.
this index, first of all, look at that description. It's a non-clustered index. We'll talk about non-clustered and clustered one. It's a
Okay.
non-clustered index. It has not saved only these records. It has actually taken the invoice total and
Okay.
created an index value where invoice total has been taken as an ascending order.
Okay.
What is that? I'll tell you. Actually, what it has done, I'll tell you. Select, for example, select everything from, let's say, from invoices. I'm just giving you example. Simarjit, you'll understand that one.
Okay.
And I would say invoices. Um, let's do that. Where? Let's use that. Where invoice total, invoice total greater than zero, for example, right? And let's say order by invoice total, and it should be ascending by automatically, right? You know what I mean? I'll just show you this one. If I run that one. Okay, now look at that. It has this ascending order in invoice total. Simajit, you see that? It has
Yeah.
created
Yes.
this table. Now this is again 114 rows, but do you see that now our invoice total is all in ascending order?
Yeah.
And if I ask you again, if I ask you find out something between 50 and 200, for example, so the amount of time that you were taking before this one would be much lesser. Why? Because you would directly start searching from maybe this point. You know what I mean? 46
Okay.
point, because it's less than 50. And
Mm-hmm.
you will stop your search at this point of time. So look at that. Maybe, few records that you will be reading instead of reading all the 114 rows.
Okay. So like it like rather than looking
Hmm,
one by one, this
exactly.
line of code will provide us the invoice total that has less than 50 and sorry, less than 200 and greater than 50.
Wonderful. Look, Simarjit, be unmuted for a second. Actually, what this index will do, if I now try to search something by using this index, and I have to find out 50 and 200, and I
Yeah.
use this index instead of using the normal table, what will
Okay.
happen? It will just go over here and it will start searching from this point, and it'll
Okay.
stop it searching at this point. It won't go to any further records. You know what I mean?
Okay. Yeah.
It says that rest are all useless. So actually on a bigger level, that would really make you see here that the time comes, the query time. And again, we
Mm-hmm.
cannot see that since we don't have that much record, but you will see that your query time comes down a lot better. Why? Because now you are not searching all the records, you are just searching a particular block of information.
Okay.
Yeah, you said so it's a sort of you can say that a virtual table has been created,
Okay.
which has an invoice and like this. I've given you this example. It has just created that one, and when I run that, it shows me invoice total for 6 and 2 typically 237,000 whatever, and it says that now if I want to find a particular so for example, if you talk about this one, greater than 0 and less than for example
200.
100, let's say. So you see that
Okay.
in that case also, it has to find out, it has to go into every row. It is coming up with the 48 rows, but it has to go every row and find out what is the invoice total in that row. But
Okay.
if that same is happened by using this index, it will actually only go to that starting row, the first row, for example, by using the ascending order. Again, this one, because this is the physical form of it. So it will use this one. It will just start from this point and it will stop at wherever you file 100 or greater than 100. It will stop at this point. It say, okay, 95 is the last value because I know that these are all ascending order. Right,
Okay.
Simranjit? Wonderful.
Yeah.
Okay, so types of indexes. Indexes can be of different types. One of the type is clustered. One of the type is non-clustered, unique, filtered, XML, full text, spatial, column store, index with included columns, index on computer. We do not use all of them, but these are the names just to remember. Now here comes clustered. This is very interesting. Clustered, which determines the physical order of data in a table. For this reason, a table can only have one clustered index. First of all, clustered index is one that determines the physical order of the table. Simarji, does it turn on a light in our mind? It actually is made on the base of primary key. Because remember, we actually, we usually find out the physical order or of the data is typically, find out. So we'll talk about that one. But anyhow, let's talk about this, that it determines the physical order of the data in a table. For this reason, a table can only have one clustered index. So all the physical order of the table is called clustered index. And the point to remember is that there will be only one clustered index per table. Now, primary key constraint creates clustered indexes. Now, that was I was talking about. Actually, primary key does what? It creates clustered indexes automatically if no clustered index already exists in the table. If I show you something, do you remember? I showed you. This was the one that I have created. Simarji, do you see that this is the one that I did not create it? I did not
Yeah.
create. PK. So this has come, and again, you can see it is clustered. Clustered
Mm-hmm.
means actually what it is doing, it is actually finding out the physical, invoice ID. It is using the physical existence of the record, which has
Mm-hmm.
nothing to do with what is the total, what is the amount. You
Yeah.
know what I mean? So that's why these indexes are like these index PK invoices is automatically created, and it has some features. Look at that: clustered, unique, primary key. So it's basically clustered,
Okay.
unique, and primary key. This is non-clustered. We'll talk about non-clustered. This is non-clustered, and this is on invoice total. I have created on that invoice total. Make sense?
Okay. Can you run the like in the SQL server? Can you select these four lines, select from invoices, the fourth, fifth, seventh, and eighth?
Okay.
Yeah,
Fourth,
can you
fifth,
select all these lines and can you execute them?
all of them. Okay.
No, till eight,
Including,
till eight,
sorry,
till the eighth line
till line eight.
on
Okay, till line.
invoices.
Okay, yes, why not? Line eight. I'll run that one. Okay. So look at that. Oh,
The
yeah. So
results.
you
It's
see
showing the
what error
message.
I'm seeing
Yeah, because an index or stats, the
is already
name
there,
is
right? So
already
I
exists.
need to drop that. I need to delete that if I want to do that, right?
Okay.
So why did you want to run this all four lines? Just for information.
Like, uh, what I have figured out is that if we are searching from
Mhm,
ascending, like the ascending order from
mhm,
0 to 100, it will start
mhm.
from a certain point and
Right.
it will go till it reaches the point in the database where the 100, it has touched 100 or maybe less than 100, like 95 or, and next to 95 will be 105. That will not
Mhm.
be come under the 100 value, right?
Mhm.
So, but now we are instead of starting up from a certain point, we are
Mhm.
directly picking up all those values like create index, IX invoice amount, on
Mhm.
invoices. So
Uh-huh.
we are picking up the particular like the amounts. For example, 50th amount is the invoice amount, invoice total, sorry, is on
Mhm.
the 60th index,
Right.
right? But and we are directly picking that instead of running up from a certain point and then going to till the 60th or somewhere in the database, then
Right.
we are displaying. So is it what we are doing here?
Okay. I'm not sure, Simajit, I got your question, but I'll try to answer first. First of all, I'll run these two commands, and I don't know if I will be, but let me know if you don't get your answer. I'm running these two commands. Like, look,
Okay.
not these two commands. Rather, I would run these two commands. Let me just give me a second. I just do that. I paste it over here, right? Greater than zero, and why not? Um, let's do that. Yes, let's do that. So I'm saying that I'm running these two commands together.
Okay.
Look at that. Now, if I show you, it's showing me if I just, just let me know, or rather, let me just run that one by one, first of all. So you see that it gives me 48 rows,
Okay.
greater than zero, less than 100, right?
Okay. So these are the
Now,
48 rows.
these are 48 rows that fall on this one, which is
Okay.
like the amount is from
The
zero to,
parameters.
yeah. So it falls on this one, right? Now, if I
Okay.
run this command,
Mm-hmm.
I'm getting 114 rows. Now
Yeah.
listen what is happening. Actually, I'm getting these rows here also. Actually, practically, I am reading 114 rows and then getting my result over here of 48 rows.
Yeah.
So when I have introduced this one, again, this is not the index, but I'm just imitating the index. If it is basically if it was indexed or ordered by, if I run that one, look at that. Now it will just start from this point, and
Okay.
actually the real execution of previous query is stopping at 95. So you see
Yeah.
that how much is there? It's 48. You saw 48
48.
rows. So it's actually I don't know if I was able to answer your question. So index is actually doing that for us, which I can do over here. You know what I mean?
Oh,
Not so I'm not able to do that by your. I was just miss that, and practically physically I can count that one, but not computer would be able to count that. Again, if I want to find out maybe multiple rows, it will still go to that particular because this is not a table. This is just the result of a query. You know what I mean?
yeah.
You might want to create as a view and later on just find out that one. You know what I mean? But that
Mm-hmm.
is that is not in consideration right now,
Okay.
right? Okay, so primary key constraint create clustered indexes automatically if no clustered index already exists on the table. So primary key will automatically create the clustered index. Remember what is clustered index? Clustered index actually determines the physical order of the data. Now, even if we insert values of ID not in sequence if giving by ID by ourselves. So now what they are saying, for example, if it is not a right now it might be an auto row that is being created over here, but they are saying even if we put some ID by ourselves, you know what I mean? So for example, I say that I put an ID by myself and I put an ID of, for example, 700 or something, whatever. So what it will do that it since it is clustered by this invoice ID, so that 700 will go to its particular location where it has to go. Make sense? It will typically go to that particular record wherever it has to just go. So now even if we insert values of ID not in sequence, if giving ID by ourselves, even then it would be because it is clustered with that one, it would typically go to its original location or the place where it has to go. Now let's do it. So they've just tried to do that. We'll just see this example and then we'll just so for example, they've just created a table. Let's do that. We'll create a table and try to do that with ourselves. So let's create this table, and I would come here and let's create that in AP. Why not? Let's create that in AP and I'll create it over here. So create table TBL employee, and let's talk about maybe not 123 because we are just making first table employee. ID integer primary key, but I'm not making it, as a, the auto increment. Let's do that. Okay, one row it's changed, and let me just refresh the tables. I've got the table. It should be there. TBL employee is there. Now let's put some rows into that one. Okay, first of all, yes. First of all, let's see that is that index is created or not. Look at that. TBL employee. Tell me how many clustered you. So you see that PK underscore TBL employed something, 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 clustered, unique, primary key, and it is ID. But it's not auto-generated. We are not auto-generating that one, right? So if I just come here and I want to insert record into that one, why not? Let's insert some data. Let's insert some data into that one. And I run all 4 commands. Oh, yeah, TBL employee 123. I'll just change it to employee, just not 123. Run that one, one row affected, one row affected, one row affected. Now let's come back over here. First of all, let's select everything from here, from TBL employee. Look at that, we have 1, 2, 3, 4, 5, even though we inserted them in the wrong sequence. 3, 1, 2, 5, 4. So now, since it has been clustered on this ID, so it really never really cares where you are inserting a record. It will take it to a particular position. So for example, if I say 30, for example, I want to insert this record with ID 30. It says that all rows affected. If I just come over here, you look at that 30 is always coming in at the very bottom.
Okay, and the unclustered one will be like in the format that we have written. It will not arrange the items like the clustered one do.
Exactly. So unclustered, non-clustered one, Simarjit. Why? Because remember that one that we have created inbox amount, because it's basically, it really does not make sense to have anything in invoice total form, because that really disturbs our structure of the table. You know what I mean? So structure of table is only saved when you have an ID typical of something that is recognizing the data and that is in sequence. But invoice total, if I start inverting invoice total, whatever will be invoice total, it might just keep on adding to that new value, the new row, because it does not have to be in a proper sequence. You know what I mean?
Yes, sir.
Okay, let's move forward. All right, so composite clustered index. There is another thing, composite clustered index. When index is based on multiple columns, if the index you are creating is based on multiple columns, that might happen at times that you have got an index value that is not typical. You remember there are lots of situations where we have to combine two fields to make one index, where their index is not enough to make it. Now let's create this, but remember only one clustered index is allowed. So delete the previous if any. So again, it's just saying that now why not let's create one more index on that, maybe on that salary. They're just trying to create that one over here. But why not let's do that for our example. They're doing that for TBL employee. And did they do that for TBL employee before, like the first one? Oh, that was for the employees. Don't worry. Okay, so I'll say clustered index, and yes, so I'll come over here and I would say, let's see. So first of all, I'll just remove the table, create index 1, 2, 3. Like to say, I create. I'm making a mistake, and I'm making a mistake. You'll see that I'm making a mistake. So I'll say, for example, this is create that IX and I'm saying create a clustered index. Let's see. Simarjit, you can guess that it should not be created. Why?
Because the database already is clustered.
Exactly, it's already
It's in the
clustered. So we don't.
clustered form.
Yes, exactly. It's all, in other words, it already has one clustered index, so
Yeah,
to speak in that way.
that
So it
is
cannot
the
create another clustered index, right? So what we
Mhm.
can do, we can just come here and we can say, for example, let's drop that one. I don't know if we can drop that one. Let's drop that. Drop. Um, what is the name of that clustered index? Oh, it's the bigger one. How do we again just find out the name?
Because I guess over here our clustered index is the ID already that we have made as a primary key.
Yeah. Yes, you're right. So let's use the drop. Unknown object. It does not recognize that one, of course. Okay, just a second, because here we have just, that one. Well, one doesn't allow to delete the previous, if any. Okay, let's go back here and see if we can delete it from the table from here. So this is our table employee. This is our index. This is our this one. And let's see if I can delete that one. Okay, delete that. So you directly implement that, we have not used the command. You might have to just look into that one. Let's see what it comes up. Oh, it's taking long. Maybe it's. Does it work with you guys? Simaji, did you try that one? Maybe delete that.
Not yet, sir.
It might not allow me to just remove that clustered one. I don't know. Because,
Actually, I haven't downloaded the file that you're working on, I guess.
oh, which one? The AP?
Uh,
No,
yeah,
here
the
I just,
database, I guess. Which database is this? Yeah,
I,
AP. I have to download
yeah,
the
you don't
AP
have
from.
AP. I shared this AP last week, in last week's class, or rather it is there on your course shell. If you go to the course shell, you will find that over there. Let me show you. If someone is looking for this database, I can show you. Where is that? Look on your course shell. If you go to this databases, look at that. This create AP. This is the one. Right,
Oh,
Simajan? Yeah, you can
okay.
you can you can access
Just a
that, and
second.
this will be a SQL file, and run that one, and you'll get AP in your system. That the
Just a
AP database.
second. Okay, databases.
Okay, it is taking longer time. Looks like it's not doing something. Well, let me
Yeah,
see
there is
that.
something going wrong on that one.
Yeah, otherwise it does not take that long, right? So let's see if we can stop that even. It's not even stopping. Good. It should give them error maybe and stop that, but not doing that. Rest everyone is following along. So is it only Simarjit who is following along with this? Can I have a comment from everyone by the time it is getting deleted? And okay or something, that shows that you have been following along these indexes and everything. And by the way, Simarjit, for those who are familiar, I can just tell you know how important these concepts are for the data analysis. If you know about that one, when you go for the analysis of data, you need a lot of these concepts over there. And you should not be surprised to see when you will go to things like, if you have heard pandas in Python, and those places where you do the data analysis, you will be really surprised to know how many concepts you have learned here, they would be implemented over there. If you know that, if someone has an interest in data analysis something, you should see that this course is much more of interest. But anyhow, so I'm stuck, so let me just do what I can do for that one. I think I'll have to just maybe give it a three-finger salute. By finger salute means Control Alt Delete, and let's see. Oh, it's now looks like it's stopped. It has stopped, and index is deleted as well. Oh, it took whole lot of word, and now it is being deleted. Simajit, you can see that it's now deleted, right? So now if I come here, and it's good that I did not have to do anything. And if I just create this clustered index, now see that index is created. And if I refresh this one, you see the index is basically created. And now this index is basically based on, if you look at that, name and salary both. It's basically on the basis of name and salary both. And it takes out what? It takes out the values over there. And if you look at that, this one, like select status from the table. So it just, brings up all those records in that form over here. And it shows me that all the records are over. And do you see that now they are not in sequence? Simaji, do you see that? They are not in sequence anymore. Why? Because the ID is no more being like using that clustered thing. And actually
Yeah.
what we are clustering it with, of course, if you can look at that one. So we have this name and salary, which is, we have salary is the ascending one, and the name is the descending one. So if you look at that, maybe it's taking that name and all those things. So name is T Paul, and it's just taking that one. So now this is indexed. This table is indexed on these two
Sir,
things, and that's yeah.
there is one thing. If salary should be in ascending,
Mhm.
so it should be from 22300, then it
No,
will go up to
you're right. You're right.
2900.
But do you see that it is doing first on name descending?
Oh,
So
okay.
actually, it brings up T Paul, and then of
Yeah.
course whatever is the salary, it has to bring that. Then comes this
Okay.
S Paul, and it brings up through 300. You know
So
what I
it is
mean?
being ignored. If even
Yeah.
if you write something after the name, it will be
Mhm.
ignored.
Not ignored. It will work where you have, for example, same name and different salaries, or same name or different, salaries. So, for example, look at that. Now, ironically, I have just put this same record. Why not if I just put something? You know what I mean? What I'm saying? It would come handy when this happens. For example, let me
Okay.
insert this record and
Hmm.
let me run this table now.
Okay.
So look at that. Look at that. Are you getting that one? The Paul is coming at the very top. You
Okay.
understand? Why? Because the Paul is there
Yeah,
is a
the salary for the poll is 2300, but the
ex-
fifth entry has 2400. So it is still working.
exact no, it's still working. But do you see that it has given preference to this Paul?
Yeah,
Why?
it is
Because
given preference to the salary which is smaller first because
exactly,
it's in the
exactly,
ascending part.
exactly. You got that. You got that. You know what I mean? So that's
Yeah.
that's quite interesting. It's making that indexing, and that is a clustered index. And if I just go there and find out the index over here, you see it's a clustered located on primary name and salary. It's just going the name and salary, and it
Yeah.
is a clustered index being created.
Like it's helpful where big companies, many employees have similar names, so it
Of
will be
course.
helpful. Yeah.
Of course, sorry. Of course, you are now getting the importance of this one, Simarjan. That's what I'm saying. For
Yeah.
example, people like Facebook, they have so many employees. There can be, there is a very much possibility that 5 employees have the same first name and last name. There are few names very common. So they have the first name and last name common. But of course, there must be something that will make them, stand out from the others. That might be its salary, that might be their but that might be their rank, or whatever. So you need to just work on that. So you see that Paul, and this Paul is coming up over here because it's actually, what? It is taking that 2300, and it's taking because salary is in ascending, so it should come first 2300, and then name is descending. So that's why name is coming up in that last one 2400, right? So that's a wonderful, wonderful discussion. Thank you. So now let's come back to composite cluster index. So we have created a composite cluster index, and that is basically working fine for us. Non-clustered index. That's another interesting fact. Non-clustered index. Let's talk about that. An index of a textbooks revisited. Non-clustered is an index book of a textbook. Textbooks. The index is not clustered. Clustered means, I told you, there is no proper sequencing of the chapters. Number is there, number one, number two, number three, but if you talk about the title of the chapters, they can be random. It can be first chapter can start with H, second one can start with B. See, the data at one place and index in another. And another very important thing is the data at one place and index in another place. So index is one place and the data is the other place. That's quite interesting fact. Another fact. More than one non-clustered index possible, where if we have non-clustered, we can have more than one non-clustered index possible. Simranjit, can you guess why we can have more than one non-clustered indexes possible? But what can be the reason?
Like in the non-clustered one, maybe the primary key is not there.
Yes. So
That's
why
why it
primary key
is.
is not there? Why more than one is possible? Because there are this is not something which is recognizing the record. So we can
Okay.
have multiple non-clustered records. And maybe we'll see that example. I think I've included an example. So let's start. In index itself, the data is stored is an ascending or descending order of the index key, which does not in any way influence the storage of data in table. So index is what? The index itself is stored in some other place, and the data is stored in other place. As the book, when we go into the book index, we'll find page number 70. So I'll go to 70 page number where there is data. So index itself is, of course, maybe in a proper ascending or descending order. We might have the page numbers from starting from 1 to 70. But when we say the data is stored at some other location, which does not in any way influence the storage of data in the table. So storage might be very different from the data that is from the indexes that are there. Now, let's come back. Reminder points. Only one clustered index per table. Clustered index is faster. Why? Clustered index is faster.
Because like first of all, there will be a primary key. Like for example, if we are not making the ID as a primary key, suppose
Mhm,
there is something else as the primary key,
mhm.
and it will be arranged in like an order. But in the
Yes.
non-trusted one, there will be no order, and we have to run a query if someone says, okay, I want like the employees that have a salary from 10,000 to 20,000 in
Yeah,
a
yeah,
proper manner. Like,
yeah.
so we have to run a query for that. But if
Wonderful.
in the clustered one, the ID is a primary key, it will be arranged automatically according to that ID, and it will be much more easier for us to find the
Mhm.
data.
Wonderful, wonderful, Simarji. That's quite interesting. And let me tell you, Simarji, this is the first time I'm enjoying taking this class because I never hear anything from students, and it really gets boring when I'm just speaking, and I'm really happy with this. Okay, so clustered index determines the storage order. Clustered index, of course, also determines the storage order of that one. And let's move forward. Then comes unique index. What is unique index? Unique index is used to enforce uniqueness of a key values in the index. By default, primary key constraint creates a unique clustered index. So index can be a unique index or not unique, for example. So if I just come over here and look at this index, which is over here that we have, how many of we have created clustered located on primary key, but this is not unique. And remember, when we create a table, if I create another table with some other name, just for the purpose, if I create a table and now I call it employee table one, TBL employee one. If I create that and I have ID as a primary key, look at that. And look, if I want to look at the plus, like the indexes of that one, I go there, I run that one. Look at that. It says clustered unique because ID is primary key and it would be unique. But look at that. The one that we have created, it is not a unique one because it's not a single column. It has multiple columns. It's not unique over there. So by default, primary key constraint creates a unique clustered index. Uniqueness is a property of an index, and both clustered and non-clustered indexes can be unique. So it is not about the type of index that would be unique or not. A non-clustered index can also be unique, even though we have this. This is a clustered one, but a non-clustered one can also be unique. Notebook, like point to be noted. So when we add a unique constraint, a unique index gets created behind the scenes. Whenever we add a unique constraint with any of the value, a unique index gets created. Come back over here. Let's talk about this one. We have another table over here, and let's see that how we will be working with this table. Let's look at that. If I create this one, let's create a table, and I'll keep this name 456. Why? Because so let's create that one. So the table is created. Now let's do what? And if I just find out again, its values. Let's do that. So clustered, you need primary key located. So when we have that one, let's move forward and let's insert into employees. Let's insert some values into that one. And again, without wasting our time, let's copy this one from here. Copy this, come here and paste it over here. Let's run that one. Now look at that. If I try to insert 1 and 1, of course, what happens is that, okay, sorry, it says this error, the value that came up. Oh, sorry. So now let's run that one. There was a different error. Now see here, violation of primary key constraint PK, this cannot insert duplicate. Now I'm trying to insert a duplicate because it's not auto-generated. I'm trying to insert a duplicate value for 1. So again, this is very, very this is very common thing. You need to drop the index to insert it. What do you think about the primary key now? So you need to drop the index to insert it. So I have to go there literally in my table. Let me just first of all go to the table. Look at that. And I have this table 456 over here. It has index. Let's see if it gets deleted a bit quickly. I don't know. Let's see if it gets deleted. It's executing, hopefully. Now, look at that, what it's doing. So it says that you need to drop the index to insert it. If I drop the index, of course, it will insert these two values because I have just created the one as a primary key. If the index is deleted, the primary key is gone. What do you think about the primary key now? Now, we'll just see that. Let it run. And it took a good amount of time. Let's see how much time it will take now. Let's see. It took a good amount of time. Let's see that how. In the meantime, I'll just copy and paste this statement here just to save our time. And first of all, again, if it runs, it means the cluster, it's not gone still now, and it cannot insert the duplicates, of course, because the primary key is not like, the index is not deleted till now. Let's see that when it will be done. Let's see in the meantime. Okay, so creating a clustered non-clustered index. So I'll try to alter the table, add constraint, right? And I'll say unique table employee 456 city. So we'll just make unique clustered of city. Let's see that, and if that works. Simarjit, is it taking that much long for you as well, or this is my system which is creating a mess of it?
I'm still doing it.
Oh, okay. Did you create that AP database just for purpose?
Yeah, yeah, I
Okay.
have downloaded it. It's in my SQL server now.
Wonderful, wonderful. That's good. I'm just waiting for it to done. Let's see when it is done. Okay. It's still taking some time. Let's see. I'll be happy to know from someone else. Maybe Simarjit is replying continuously. Can I have anyone else coming up and they say that how much time their deletion is taking, because it's taking a lot of time for me. Still taking time. Okay, it's taking much more time. And this is good, in the meantime, Simajit, you will be able to just, install your things.
Um, this SQL file, the API SQL file, um, to
Yeah.
add it into the databases. So
Hmm.
first I have the back file that the Northwind named as Simarjeet, and I have sys file. So to add the AP file, I have to go to databases and then store databases.
Oh, no, no.
It's no, it's for the back file. Okay.
Oh, for the backup file?
No, it's the AP is a SQL file, so
SQL file.
I
Yeah, yeah.
can
So
have.
you know what you need to do? What you need to do? Would you mind if you want, you can share your screen. I can guide you.
Okay.
Do you want to share your
Just
screen?
yeah, just a second.
Sure, sure, sure.
Can you see now?
Yes, I can see that. Yes. So can you open this? Yeah, this AP file that you have there, AP file.
Yeah.
You might want to open it with Notepad, maybe. No worries. You know what I
Okay.
mean? I
Yeah.
just want to have the. I want to have the. Yeah. Now copy this all. Copy this all. Control A, Control C, and go back to
Yeah.
your visual, like SSMS. Yeah. Here, maybe open a new query. Or
Okay.
you maybe you have that already. Oh, okay, no problem. Just and paste that all, and now execute.
Okay.
Wonderful. Now you refresh your databases. Refresh your database.
Okay.
You get this AP, right?
Yeah. Okay.
And these are tables, and you can just practice whatever we have just done, right?
Yeah. I'm on it now.
Okay, wonderful. So now this is interesting. It's still not done, and I don't know. I'll have to just maybe let's let's try that down. Maybe sometimes it's working. It has started working. Still it is the same thing. I don't know. Let's see that. Let's see that. Okay, so it's a 2:02. Let's take a break for that matter for 15 minutes, and we'll be back with some fun stuff, right? So let's take a break. It's 2:02 in my clock. So I'll be back around 2:17 p.m. Right? So can I have everyone just put a message and leave? And in the meantime, it might get deleted, thankfully, and we will just
Mm.
be back with that. Thank you, Simarji. Thank you very much.
In the meanwhile, can I ask things that I wanted to ask?
Simarji, after the class, no problems. I'll be there,
Okay.
right?
Okay. Okay. No
Okay.
problem.